Modules. We know from experience it's unruly to have all of our functions in the same file and scope. In this lesson, we're going to cover how to group functions and define a specialized map known as a struct in order to organize our code more efficiently. Modules allow us to organize functions into a namespace. In addition to grouping functions, they allow us to define named and private functions, which we covered in the functions lesson. Let's look at a basic example. Def module example do define your method. It's possible to nest modules in Elixir, allowing you to further namespace your functionality. Module attributes are most commonly used as constants in Elixir. Let's look at a simple example. It's important to note that there are reserved attributes in Elixir. The three most common are module doc, documents the current module, doc, documentation for functions and macros, behavior, use an OTP or user-defined behavior. Structs. Structs are special maps with a defined set of keys and default values. A struct must be defined within a module, which it takes its name from. It is common for a struct to be the only thing defined within a module. To define a struct, we use def struct along with a keyword list of fields and default values. Let's create some structs. We can update our struct just like we would a map. Most importantly, you can match structs against maps. Composition. Now that we know how to create modules and structs, let's learn how to add existing functionality to them via composition. Elixir provides us with a variety of different ways to interact with other modules. Alias. Alias allows us to alias module names, used quite frequently in Elixir code. So we have this alias so that we don't have to prepend this part of the namespace without alias. If there's a conflict between two aliases, or we wish to use the alias to a different name entirely, we can use the as option, as high. It's even possible to alias multiple modules at once. Import. If we want to import functions rather than aliasing the module, we can use import. I'll bring everything into the current namespace. Filtering. By default, all functions and macros are imported. What is taking so much, or why is it monosnap? What in the world? Alright, should help a little bit. Filtering. By default, all functions and macros are imported, but we can filter them using the only and except options. To import specific functions and macros, we must provide the name/arity pairs to only and except. Let's start by importing only the last function. If we want to import everything except last and try the same functions as before. In addition to the name/arity pairs, there are two special atoms, functions and macros, which import only functions and macros respectively. Require. We can use require to tell Elixir you're going to use macros from another module. The slight difference with import is that it allows using macros, but not functions from the specified module. If we attempt to call a macro that is not yet loaded, Elixir will raise an error. Use. With the use macro, we can enable another module to modify our current module's definition. When we call use in our code, we're actually invoking the using one callback defined by the provided module. The result of the using one macro becomes part of our module's definition. To get a better understanding how this works, let's look at a simple example. So we have a def macro, using and ops, but they're currently not used. Here we have created a hello module that defines the using callback, inside of which we have defined a hello function. Let's create a new module so we can try out our new code. We're now going to be able to example.hello. Yeah. Here we can see that use invoked the using callback on hello, which in turn added the resulting code to our module. Now we've demonstrated a basic example. Let's update our code to look at how using supports options. We'll do this by adding a greeting option. Default high. Let's update our example module to include the newly created greeting option. It's like use plug. If we give it a try in IEX, we should see that the greeting has been changed. These are simple examples to demonstrate how use works, but it's an incredibly powerful tool in the Elixir toolbox. As you continue to learn about Elixir, keep an eye out for use. One example you're sure to see is use xunit.case async true. Note, quote alias use require, quote alias use and require are macros used when we work with metaprogramming. Mix. Before we can dive into the deeper waters of Elixir, we first need to learn about mix. If you're familiar with Ruby, mix is bundler, Ruby gems, and rake combined. It's a crucial part of any Elixir project, and in this lesson, we are going to explore just a few of its great features. To see all that Mix has to offer, run mix help. Until now, we've been working exclusively within IEX, which has limitations. In order to build something substantial, we need to divide our code up into many files to effectively manage it. Mix lets us do this. Mix lets us do that with projects. New projects. When we're ready to create a new Elixir project, Mix makes it easy with the Mix New command. This will generate our project's folder structure and necessary boilerplate. This is pretty straightforward, so let's get started. Mix New example. From the output, we can see that Mix has created our directory and a number of boilerplate files, creating readme, getignore, mix.exs, mix.elixir, exs, config, lib, test, then example test. In this lesson, we're going to focus our attention on mix.exs. Here we can configure our application dependencies, environment, and version. Open the file in your favorite editor, and you should see something like this. Comments removed for brevity. Def module example.mix file. Use mix.project. Def project. Have some deps. Application. Extra applications. The first section we'll look at is project. Here we define the name of our application, app, specify our version, Elixir version, Elixir, and finally our dependencies, deps. The application section is used during the generation of our application file, which we'll cover next. Interactive. It may be necessary to use IEX within the context of our application. Thankfully for us, Mix makes this easy. We can start a new IEX session with IEX -S, the capital S flag, Mix. Starting IEX this way will load your application and dependencies into the current runtime. Compilation. Mix is smart and will compile your changes when necessary, but it may still be necessary to explicitly compile your project. In this section, we'll cover how to compile your project and what compilation does. To compile a Mix project, we only need to run mixcompile in our base directory. There isn't much to our project, so the output isn't too exciting, but it should complete successfully. When we compile a project, Mix creates a _build directory for our artifacts. If we look inside _build, we see our compiled application, example.app. Managing dependencies. Our project doesn't have any dependencies, but will shortly, so we'll go ahead and cover defining dependencies and fetching them. To add a new dependency, we need to first add it to our mix.exs file in the deps section. Our dependency list is comprised of tuples with 2 required values and 1 optional. The package name as an atom, the version string, and optional options. For this example, let's look at a project with dependencies like Phoenix Slim. As you probably discerned from the dependencies above, the cowboy dependency is only necessary during development and test. Once we've defined our dependencies, there is one final step, fetching them. This is analogous to bundle install and is accomplished by mix deps.get. That's it. We've defined and fetched our project dependencies. Now we're prepared to add dependencies when the time comes. Environments. Mix, much like Bundler, supports differing environments. Out of the box, Mix works with 3 environments: dev, the default environment; test, used by mix test, covered further in our next lesson. Prod, used when we ship our application to production. The current environment can be accessed with the mix.env, using mix.env. As expected, the environment can be changed via the mix_env environment variable. Sigils. Working with and creating sigils. Sigils overview. Elixir provides an alternative syntax to representing and working with literals. A sigil will start with a tilde, followed by a character. The Elixir core provides us with some built-in sigils, however. However, it is possible to create our own when we need to extend the language. A list of available sigils include capital C generates a character list with no escaping or interpolation. Lowercase c generates a character list with escaping interpolation. Capital R, regular expression, so R is regular expression. S, string. W, word list. N creates a naive datetime struct. A list of delimiters include pointy brackets. Oh man, can't believe I have not been calling them pointy brackets my entire life. All right. All right. Curly brackets, square brackets, parentheses, pair of pipes, pair of forward slashes, pair of double quotes, pair of single quotes. Char list. The C sigils generate character lists. For example, with interpolation, capital. We can see the lowercase c interpolates the calculation, whereas the uppercase c sigil does not. We will see that this uppercase/lowercase sequence is a common theme throughout the built-in sigils. Regular expressions. We can create them either on the fly or for use within the regex functions. We can see that in the first test for equality, that Elixir does not match with the regular expression. This is because it is capitalized. Because Elixir supports Perl-compatible regular expressions, we can append -i to the end of our sigil to turn off case sensitivity. Further, Elixir provides the regex API, which is built on top of Erlang's regular expression library. Let's implement regex split 2 using a regex sigil. As we can see, the string 100 million is split on the underscore thanks to our underscore sigil. The regex split function returns a list. String. The S sigils are used to generate string data. What's the difference? The difference is similar to the character list sigil that we looked at before. The answer is interpolation and the use of escape sequences. If we had another example, capital interpolation. or lowercase interpolation. Yeah. Word list. The word list sigil can come in handy time to time. So every space we get an array. We can see that what is typed between the delimiters is separated by white space into a list. However, there's no difference between these two examples. Again, the difference comes with interpolation and escape sequences. Naive datetime. A naive datetime can be useful for quickly creating a struct to represent a datetime without a time zone. For the most part, we should avoid creating a naive datetime struct directly. However, it is useful for pattern matching. For example, creating sigils. One of the goals of Elixir is to be an extendable programming language. It should come as no surprise then when you can easily create your own custom sigils. In this example, we will create a sigil to convert a string to uppercase. As there is already a function for this in Elixir core, we will wrap our sigil around that function. First, we define a module called mySigils, and within that module, we create a function called sigil_u. As there is no existing u sigil in the existing sigil space, we will use it. The _u indicates that we wish to use u as the character after the tilde. The function definition must take two arguments as an input and an input and a list. All right. That's all for today. See you.